Okay, this would be the last video for our momentum transfer course. Ano? So this video will tackle the weir. So the weir is usually maintained is usually used to maintain the height of a liquid in certain equipment like distillation column. Pero it is also used to measure it can also be used to measure the volumetric flow rate. So let me share the PowerPoint. So a weir is defined as a barrier across the horizontal width of a river, no? So it could be a river, it could be a distillation column, uh, it could be a rectangular pipe system. So it alters the flow characteristic of the liquid, no? And usually results in a change in level, no? In the vertical height of the liquid level. So as I've said, you can also use a weir to measure the volumetric flow rate. So there are empirical equation that relates the dimensions of a weir to the volumetric flow rate of a particular liquid flowing either on a pipe or in a canal. So let's take a look at some equation. This is from our handbook on page 24, 10-24. We have here the Francis formula. So it describes the equation. This is an empirical equation for a rectangular weir. So as you can see, you can use 10-40, mas simplified siya compared dun sa 10-39. This is the simplified form of 10-39. So just multiply 0.386 to the length of the weir. This is the length of the weir. And then the height, HO, we raise that to 1.5. Okay, so ang dimension nito currently is 2.5 with respect to, halimbawa, feet or meter, no? Feet to the 2.5 or meter to the 2.5. Then multiply that with square root of 2g. So square root of 2g, this is the acceleration due to gravity. So for SI, this is 9.81 meter per second squared. So pag kinuha mo yung square root ng meter per second squared, you're going to have m to the 1/2. So m to the 1/2 times m to the 2.5, you will have m cubed. So yung second squared, yung second squared will become second. So ang unit nito, pag sa SI, pag puro SI yung ginamit ng unit, it would be cubic meter per second. No? So ganun din. It's the same story sa sa English, ano? So ito magiging feet raised to 2.5. Tapos ito feet per second squared. So magkakaroon kayo dito ng feet to the 0.5. So that will be cubic feet per second. Pag naman puro English unit yung ginamit nyo, puro feet, tsaka feet per second squared na G. No? So this is the Francis formula for the weir. So next is the triangular weir. So the triangular weir, you can also find this equation on 10-24. This is the empirical equation. Ano? 0.31 times HO. HO is the height of the liquid, as you can see in this illustration. So raised to 2.5. So if you're going to use feet, you're going to have feet to the 2.5. And then again, you have the square root of 2g. If your g is 32.174 feet per second squared, you're going to get feet to the 0.5. So this will give you feet cubed per second. So divided by tangent P. So the P is this angle, ano? This angle. So kung given yung angle nung triangular weir sa loob, so probably just divide 180 minus this angle divided by 2, yun yung magiging P. No? This is your theta and this is your P. So tangent P. Okay? So these are the empirical equation. So ganun din, kahit na SI. So pag SI, yung magiging Q ay cubic meter per second. So let's try to solve the MRI reviewer problem. A right angle triangular weir is used to measure the flow rate of water flowing in an open channel. If the height of the water in the weir is 7.8 inches, the flow rate of water in gallons per minute is blank. So let's try to solve this in this so just basically substitute everything sa ano ating empirical equation. So probably a drawing will help ano. So we have a triangular weir. Yun. Okay? Right angle triangular weir. Ibig sabihin ito 90 degrees. So if you're going to draw a horizontal line right here, siguro naman makikita nyo na this is 45 degrees. So ibig sabihin nito, your P is 45 degrees. Okay? Yun lang naman. Ano? Tapos the height of the liquid is given as this is 7.8 inches. Okay? So if you can recall our equation for flow rate for a triangular weir, that would be 0.31 HO raised to 2.5 and then square root of 2G. Okay, that's the gravitational acceleration due to gravity. Tapos tangent P. Make sure that your calculator is in the degrees mode. Ano? So just substitute the values from the problem. So 0.31. You need to convert this 7.8 inches to feet. So it will be 7.8 divided by 12. And then raise that to 2.5. Tapos square root of 2 times 32.174. This is feet per second squared. No? Tapos divided by tangent P. Tangent 45 degrees. Okay? So yung lalabas dito ay cubic feet per second. So just use your calculator. 0.31 times parentheses 7.8 divided by 12. So raise HO to 2.5. Tapos multiply that by the square root of 2 times 32.174. Tapos divided by the tangent of 45 degrees. You're supposed to get 0.8471, ano? And from our dimensional analysis, this 0.8471 is in cubic feet per second. So we need the unit to be gallons per minute, ano? So if you still remember, there are 7.48 gallons per cubic feet. And then there are 60 seconds per minute. So the product will give you 380, no? So Q is equals to 380 gallons per minute. Okay, so that's it. That's how simple Weir calculation is. Direct substitution to an empirical equation in the handbook. So I hope you have the 8th edition handbook, either ebook or physical handbook. Okay, so kung meron kayo nung 9th edition, paki-check kung available pa dyan, ano? Kayo nang bahala. So hanggang dito na lang. Tapos later I'm going to post the final exam. Bye-bye for now.